Good morning, good afternoon, and good evening, everyone, and thank you for joining us today. My name is Sandra Alemani from the Institute of Biomechanics of Valencia. I am co-chair of the Anthropometry Technical Committee of the IEA, and together with my co-chair, Dr. Jude Choi Rocas from the US Army, we are organizing a series of webinars focused on anthropometric data, methods, and applications across a wide range of fields. Welcome to the 5th webinar in the series. Today is my pleasure to introduce our speaker, Dr. Johan Molenbroek, Associate Professor in Physical Ergonomics and Industrial Design Engineering at Delft University of Technology. Professor Molenbroek specializes in anthropometry, inclusive design, product safety, and export equipment, among other applications. And today he will present the webinar entitled 50 Years of Design, Engineering, Anthropometry, and Overview. Before we begin, I would like to just give a brief organizational note. You can submit your question at any time using the Q&A section of the Zoom platform. We will address them during the discussion at the end of the presentation. And without any further delay, I'm pleased to give the floor to Professor Johan Molenbroek. Johan, the floor is yours.
Thank you, Sandra. It's really a pleasure you invited me. And it's also a great pleasure to tell the audience about the last 50 years in my experience in anthropometry. The next slide, yeah. A little bit about me. In fact, you have heard it from Sandra, so I can leave this. So an overview, 1975, I was an engineering student, and then I became a lecturer at TU Delft, and my assignment was, can you explain the variation of human body dimensions to design students and to teach them how to use it? And so I started to, and it was an ideal situation because I could read a lot of books, for example, Snyder from US and Anthropometric source books, and I will show some examples later. And then I could start measuring case studies, for example, elderly, children, handicapped students, and I learned from doing those cases. And also I was at the same time I was a contributor to SEN and NEN standard committees. So I learned from what I called in those times also 1D dimensions, but later I learned very fast that scatter plots was ideal for designers because you could see immediately the correlation between two dimensions. And later, much later, so I did a lot of work with 2D scatter plots and analyzing it. I will show you later. And much later, 3D and 4D and 5D. 5D is a very simple definition of myself. I will tell you later. Then it was an idea of mine about DINET. DINET was started with an idea of my supervisor those days in 1979. And he said, why not shall we make an estimation of Dutch adult people based on the DIN 33402. And so, but we adapted the DIN data a little bit because the Dutch people, we compared the stature, Dutch people were a little bit taller. So that's how the first DINET started with one sheet of A4, and it was used until later we made it a digital model of it. Okay, let's go to the next one. Yeah, when I was a student, I got a glimpse of anthropometry, seeing a table. It's a famous data set from US flying personnel 1954. And when I was studying ergonomics, it was, let's say, 1/4 of a page in an ergonomics lecture book. Not much explanation about that. And then when I tried to use it, I was wondering, how can you use it if you want to design school furniture, if you have data of American soldiers, and a lot of other questions, like this one. I learned that anthropometric data are depending on the following criteria. Is the measurement done according to standards like CEN, ISO, British standards, and other, or DIN? If not, and that was the first part I learned to read. I did review a lot of papers, and when I saw it was not standardized, and of course I sent back to the author, please use a standard, because otherwise we don't know, you can't compare the data. And also very important is the durability. Do you know when the data are measured? If you don't know, and for example, in our country, we had a lot of circularization in height, late third, and now in weight. And that makes the tables or the data have little application. And people should know, designers should know if the data still can be used. And of course, the measurers need to be trained with repeated and measurements. So that's also what we did with students. I could learn from our cases that if I ask some students to measure a person 3 times or 10 times even, just to see what happens, then you see a lot of variation. And if you ask a person to be measured by other students, you see also differences. So I learned from those experiments and comparing data that a human body is not as precise as a metal product. So you have to learn to keep it as precise as possible, but it's a human body. And also another part of knowledge is nobody is average. I see that a lot in, for example, education of architects. They use always average bodies, and they are nice in the illustration, but in fact, they don't show the variation of the human body. And also, what I learned in the past, that a difference between countries is often smaller than the differences inside a country. That's also good to know. In my PhD in 1994, I listed 4 causes of mistakes. One is lack of knowledge about anthropometry, a lack of data, unusable tables, or wrong data. And then I got a lot of insights if the famous human scales of Dreyfus. I liked them very much because it was the first tables. They had as well human as well products. And they studied the interaction between those. And that is in fact what we in our Faculty of Industrial Design and Engineering always teach students. It's not only the variation of the human body, but also see the influence on the comfort when you're using a product or a system. And Dreyfus showed it, but when you study Dreyfus more precisely, you see that he did never publish how he collected the data. And I think there's a lot of estimation. And also, if you use it for a Dutch female, for example, the data are not usable because the Dutch female are much taller than published on Dreyfus. So it's nice design. And in fact, what I try to do with Dynet is also, and one master student of me made a concept of this system in 1998. So start with a product and ask a person, what do you want? For example, designing a chair. Then the system would say, oh, then you need lower leg lengths. And the variation of your target group is from here to here. And then you work on with other dimensions. So the system would give you relevant dimensions and relevant percentiles, and you could design accordingly. But that system never finished, because 45 years I worked at university is already gone, and I still don't have the system, so somebody else has to design it. Then also a famous source was Snyder. Snyder, 75, 77, he measured thousands of children in the US with a bus. And he had a computer, and he even had pressure sensors in his Anthropometer. So I liked it very much. And one of the workgroup members was even capable of publishing the data online. The name was EntroKit, I think. And then DIN 3342 was also a famous source for me, because I know the author, Professor Jurgens from Kiel. I was trained by him when I went to Kiel. It's only 6 hours driving. And I learned from him a lot how to measure people. And then also, much 100 years older, Martin, a Swiss professor, he did publish a lot of data from more than 100 or 200 years ago, and it's still usable. And it was very impressive to see this, let's say, anthropological study, but the physical aspects of it. And then also in those days, Anthropometric Sourcebook, 1978. You can still find it also on internet. And there are 3 volumes, and they are more than 900 dimensions defined in it, and also about 100 populations. Even there's a Dutch population in it called Dutch Woman, and it was a professor here at. He was in fact a marketing professor for a large company. Bijenkorf is called, so about textiles, and he was designing a sizing system for that company. And I'm very proud on that book. And the sizing system was different than the United States had. Mostly they had, United States had body height and body weight as 2 key dimensions. But Sittig and Freudenthal, that the authors, had back length and waist circumference, because they could statistically prove that it was a little bit better to exclude as less as possible for women clothing. But when I called the Bijenkorf in around 1980, they said, we don't know that research, because it's already 30 years ago. I also learned a lot from NASA tapes when I did my dissertation. I could just buy those tapes and do the analysis myself. And further, the Dutch crow studies, maybe they are famous, I'm not sure, but one of my professors, promoters, is Hans van Wieringen. He did the 1975 study himself. Maybe it's good to give an impression. They measured 40,000 children in the Dutch cities as a part of the youth health care. And he did a dissertation on that study. And I learned a lot about that. And for many years, that was the only study we had about body measurements, apart from the conscripts for the army. But they stopped a certain moment. So we don't have the data of a lot of Dutch people. That's why we started the DINET. Okay, then go to the next slide. DINET was born. It was just an A4 paper with 27 body dimensions. And then I was surprised that it was used by the Dutch standards called NEN, and they used it as a recommendation for designers. And even I sometimes got a message from a company. They asked me, I have a design of a chair which is 5 millimeters off of your advised data. Can you write to me that or confirm that this is still a good product. And of course I can't, because it was an estimation, our data. So our data was also taken as precisely and being the truth. And it's also what we have to, as anthropometrists, we have to teach. Our data is not that precise as the numbers show. So we have to, in our education on anthropometry, we have to teach them. Then I was trained, as I said before, by Professor Jurgens in Kiel, and so I took this knowledge with me and use it for measuring students and teaching students to measure other groups, and but as well children, elderly, people with disabilities, and also we created all kinds of formulas to add dimensions, or formulas to add populations. For example, what happens if you have 25% of male and 75% female? How does the mean and standard deviation change? We created formulas for that, and we tested them with own collected data. And in my dissertation, you can see how they are tested and what the result was. And okay, then my first project, a real project, was measuring elderly, called GDVV in The Hague. And the director of the nursing home, he had 1,200 residents, asked me, I want to buy new chairs for the people. Can you measure the leg length? And I had already some experience with measuring students and also elderly and children. So I asked him, can we also measure something more? And he said, okay, that's fine. What do you need? I said, yeah, I need, in fact, a few staff members to be trained by us. And because your staff members are coping well with elderly. And he said, okay, then you train them. I asked a few staff members, doctors and nurses. And so I taught them how to measure in millimeters, because they were not used to. And we had, in 6 weeks, I think we measured in 1982, those measurements with a measuring chair. I made more or less a copy of the Loughborough. They had published a paper also measuring elderly, and I also went to Loughborough in UK and compared. In my first international paper in applied economics, I compared also our data with those of UK. And the Dutch report we made was delivered to designers and architects, and they used it. It was frequently used, and it was also published on. It's still on the DINET platform. And we also, in those days, we had also a first computer model, very simple model with about 23 links and 144 body points. So a very simple model, but it was widely used by our students. And maybe an anecdote about measuring elderly was that it took, we want to measure in indoor clothing, and the shoes, we didn't want to measure with shoes, so we asked them, the first 10% we did a tryout, but taking out the shoes for elderly was sometimes taking 15 minutes. So we decided to have the shoes on and measuring the heel height, because it's much more efficient to measure the stature, including the shoes, and then subtract the heel height. And we learned a few things from that. I think it's the next slide. Yeah, this was my first insight about scatterplot. And then I used SPSS in those days, and later SAS. And I was very surprised when I saw the relation between buttock popliteal depth and elbow rest height. It was a correlation of 0. And then the consequence for designing is then that your armrest need to be adjustable, because otherwise you can't use. When I use my mouse, the lowest measurement was about 14 centimeters, and the highest was about 30 centimeters. So that was a large difference. And those days you saw that the elbow rest height mostly was about average 23. Now currently you see that lot of chairs have, in cars and in office, have adjustable chairs. But from this data you can conclude even more. You can define how much the adjustability should be. And that is what you learn to students or designers if you have a scatter plot of data. So a scatter plot is very useful for designers and also for anthropometrists. Okay, we go further.
Welcome to Artec's video lesson.
Oh.
In this lesson, you will learn how to scan a human body with Artec EVA.
That was a dimension further. And later we also bought a 3DMD system. And then we could measure people even in 4D because it measured, it took a picture from in every 10 seconds from a lot of cameras. And that was very useful. This was also a remarkable person. He is 200 kilograms and his waist circumference is also 200 centimeters. And that was very surprisingly. So that means also, and when he was sitting down, he could walk a little bit, but he came on a scooter mobile. When he was sitting on a chair at a table, then because of his large volume, only his wrist could lay on the table, because the other body part was taking so much room. And later he asked me also to make a kind of a harness for him, because his belly was falling down. And so he was asking the company to making a kind of a harness that would lift his belly a little bit more. So I then a little bit on. I had more than 300 final students, and they did marvelous jobs like this one, Stefan van Zegelen. He designed, that was also his assignment, to make a new helmet based on 3D scanned head shapes. And that was, I always was surprised by some students how fast they could program in Python or in what else, and to show different models. And that was, I will show a few remarkable students. This was another one. In 2014, Peter Smakman, that's this guy, came to me. He wanted to graduate on something with 3D, because every year I explained to all the students. We had 2,000 students in our faculty, and each year 100 were in a master, starting a master. And in that starting master course, we trained them to do something in 3D. So we asked a company, with the Artec dealer, we asked them to come with a few scanners, and we had also some our own. And then we asked the students to measure some body parts in 3D, and they were inspired, and they came later back. Can we do a graduation project? So this guy, Peter Smakman, also, and I asked him, can you scan a hand in one click? Because I had troubles with the Artec scanner. You can scan a hand, but then if the scanner was on top of your hand, it also scans the floor or the table or whatever. And so if you move it around, it was difficult to get a 3D hand scan. So he designed, he liked the assignment, and this was his first prototype. And later you can see on this sketch, I will show in a minute the final prototype. He made a company from his, I think it will show now this. Yeah. Okay. Now this is, oh yeah, this is what I'm looking for. This is the 3D scanner they made. And these are the two guys who invented it. And after they graduated, and now they have a company with 80 staff and running very well. And this is an orthopedic surgeon who just helped them to give an assignment to make an orthesis for the hand, the different reasons. And yeah, this is a very successful company starting from a graduation project. And then another successful student was this lady. And she scanned her own body and then put it in a 3D online world and made also furniture in it. And then you could see if it would fit or not. I liked the system very much, but she spent a lot of time to improve it. The next assignment would be, can you also show how much it doesn't fit? How many centimeters is there between the body and the table, or the body and that she couldn't do yet. I think it's still possible, but that was also a very intuitive and very experienced young woman. And then some overview of projects we did. I showed you the elderly, CDVV. Then I measured also 350 students, 50 dimensions. And later I asked the prevention fund in a national fund to support us. So we could measure 2,400 children. And there was the lady that was working on that as a lead also did a dissertation on that project. You can also find it at our library. Bea Steenbecker, she was called. So we used those data also very in DINET. And then later we did another project in '98. We called it Cheron because we measured 600 seniors, 150 young adults, and about 80 variables. We measured also the eyes and the ears, but on anthropometry we had about 79 variables. You can also find it in DINET. And it took us 5 years to measure in a traditional way. But what the most important was on this project, we could compare the data of the elderly with 150 young adults. So that was the first time we could really measure people between 20 and 30, not being a student. And then another project that was also a European project. We did a little bit anthropometry in it. When we designed with 8 countries together, we tried to, that was the assignment from European Commission, can you design a friendly restroom for elderly so they can stay longer at home? And we needed a little bit anthropometry in it, but it was not a major task in there. And when I almost did retire, and we measured again some students, and we could compare the students with the students of 1985. We also wrote a publication about that. And then, yeah, 4D, that was on the 3DMD. We had a student from Amsterdam who wanted to know what is the rotation point of the shoulder. And so we had some sportive students, about 10, I think, and they all made some movements for the 3DMD scanner. And then we could determine the rotation center of the shoulder in 3D. And that was also published by a student, Rosevink and Toon and me. And then if you collect all the measurements data, measurement equipment we have now, is the 3DMD, but also for the kit scan, we use the ScannerLogic scanner. Also we have a 3D foot and hand scanner, and also of course the ATEX scanner is still by students used very much because of all small projects, and they learn to cope with it and see that the blue one is very precise and the other one is the most general one. Let me look at the time. It's now 30 minutes ago. Okay, this was also a famous one about 4D. Was a student who was part of the human power team. And we have a lot of power teams that do a certain topic for a group of 25 students, work very hard a whole year on a certain topic. One of the topics was make a bicycle, and they came to us, can you 3D scan, or in fact it was a 4D, because we asked her to sit on for the 3D MD scanner, and we made 10 pictures every second, and to see how much space does her foot take in the room, so we could make a cabin around her foot to have a less problem with the wind. And she did win the world record, 122 kilometers per hour. So we like that kind of projects too. Then we also in 2010, I think, 2 years before the Olympic Games in London, we were asked to measure 3D the female elite swimmers. And that was a special project because in Eindhoven they have a swimming pool where a lot of characteristics of the female or the swimmers can be measured underwater and on top of the water. And we learned a lot. And what was impressive for me was that those ladies, they earn not much money, not like football players. But they spend 26 hours per week for their training. And so we had to be there, listen to the coach. The coach is the boss, and he decides when we could measure the ladies. It was mostly, we could be there at 6 o'clock in the morning. So I think how much I have a few slides of it. What we did is measure the shape of the body, and also we had a designer made a swimsuit for them. And of course you have a lot of rules for a swimsuit, which part of the body should be covered and which part that's a little bit freedom, and also but not how tight should a swimsuit be. And the swimsuits we designed, and they are in the market, are more or less like harnesses, so very tight and depending on the shape of the body. And the coach was happy that we could measure the ladies, and the designer could use the data to make a new swimsuit. In fact, we had a new design, but only 2 weeks before the Olympic Games started, we were not. The coach was not very sure about that the body, the parts of the swimsuit were tightly connected to each other. So they had to be tested. And because they were not tested yet, they were afraid, those ladies have a lot of muscles, they were afraid that the swimsuit would not stay together. So our suit was not used at the Olympic Games. But we learned a lot from that project. And we had a lot of admiration for those ladies. And then we talked about 1D, 2D was very impressive for me, 3D also. 4D, I showed a little bit about it, and I know that IBV showed recently a lot of new ways, new publications about 4D. And 5D, what I meant with it is what Toon showed a little bit in his, when we had a project about measuring children, we discovered that if children we had to design face masks for children, and the face of the children during the growth, you will see that the point from the chin to the nose is growing much faster than other parts. But also if they lie down at night on the pillow, then the skin on the soft part is impressed and the bony parts not. So that is what I called 5D. So it's an extra dimension that should be discovered in the future, because you have on your body you have soft skin and sometimes thick layers, and sometimes it's only bone but you measured, and the difference between that, I think you could call it 5D under pressure in a human product context. And then another project I had in mind to show you is there was a person who was not so tall, 193, and he bought a new car, a BMW, and he did not fit in it. At least he had bought it, but then he sued the salesman. He wanted to give it back, and the reason was I am sometimes asked as an expert, how is that possible? And so I measured him. Also, I videoed him while he stepped in the car and he stepped out the car. And then I discovered a very particular body characteristic of him. His body height was not that tall, 193, but his thunk was very. In this graph you can see the sitting height was extreme. He had an 103 centimeters body height, and most of my students are inside the ellipse, so he was outside all my students, and that was also the problem, because the BMW he bought was very sportive one, so he had to sit a little bit relaxed to see the lights of the traffic, and he didn't like that. But the judge used our data, and he said the salesman does not need to know so much about ergonomics. So you as a buyer, you have to pay the lawsuit, and you have to pay the researchers. And in the meantime, he had already bought a new big car with a lot of headspace. But I like to do this kind of research. And also, it's also an example of what you can see from what kind of insight you can learn from a scatter plot. This also an insight I learned from the elderly measurement, that the reach height was the most important measurement, because a lot of elderly, I learned from the first elderly project, can't reach above their eye height. So if they can't reach the eye height, you see an example on the right, and they have to reach for a handle, then they go stand on a stool, and then they fell down. So you have a lot of accidents in elderly. There's also, I used this data when I did teach product safety. A lot of accidents in elderly happens because of they can't do what they did in the past. And we made a nice tool for that also on Dynet, so the students can see what the reach height is, and also we asked this data from this are from the second elderly project called Geron. So we asked all elderly to draw a line on a large whiteboard from the top to the bottom, and then we videoed all the data, and we put them in this graph, so you can see it's in fact in Dynet is an interactive graph. And then when Toon was my successor, and he already started with making, because he's a computer scientist, so he was much more capable than me to work with 3D mannequins. And also this is one of the examples of Dynet currently. You can show mannequins, but also you can show where are the mannequins in those ellipse positioned. And this project is done from CESA data. You can also use other data. We have also instructional videos on Dynet, and a special part for hands, and So DINET is widely used, and we see that in this graph that how much DINET is used in public sector and government, in design engineering, and much less in what we thought in furniture architecture, for example, because the architecture students don't learn about, are not taught in ergonomics, unfortunately. So, and then currently we are also, some students are working on AI on DINET. And I recently had a review with that student, and that is remarkable for the next future, because he used Claude, that also I use Claude daily, but he used it to help designers to ask questions to DINET database, and that gives a lot of extra knowledge. This is the team from the KidScan, where we measured together with IBV, and we measured more than 2,000 children. This was a project, a reason why we did KidScan, for example. This is a terrible accident with a finger of a children. When we had in The Hague, they had spent 1 million of making new seats, because the hole for the rain to drop through was a little bit too small for the fingers of the children. So after 4 children had been hospitalized, the government decided to make new seats in all the bus stops. So that's one example we use, that why it is necessary that you measure, you have the right data for children. Yeah, then about, I'm almost finished, I think. Yeah. From European Standardization Committee, I worked a lot for CEN, for school furniture. And now we got involved in the measuring KidScan. And there were a lot of, I was impressed by how much time now was spent to the ethical aspects of the project in comparison to 40 years ago. 40 years ago, you could just take a paper and you ask a person, can you sit down a moment, I will measure you, and you get a copy of the measurements. And now I think my successor, Toon, did spend maybe more than a year. I think Sandra will know more about that, maybe she spent even more, to follow the European guidelines about ethical aspects. And one of the problems is, for example, the people in the registration ask you to destroy all the data after half a year. But that is something you don't want to destroy. You want to keep the data as long as necessary for applications. So you have to explain a lot of things. Yeah, this is a picture of measuring equipment we had in our lab. And also we make them children friendly. And this was the room where we could measure the children. And it's now all, yeah, it was, we had a lot of help. That is good to have design students, because they come with a lot of creative ideas and colors and playful. And also you have to have regular breaks, of course. This were the coalition of a group of people, organizations who were involved. And this shows the number of children measured during the 3 years. Yeah. And you see that measuring teenagers is not so easy. So it's difficult to get the teenagers to your lab, and with all kinds of promises. But it's at the end was succeeded. We measured 2,100 measurements. We measured 2,100 children. 76,000 manual measurements, 6,000 3D body scans, and 2,000 3D foot and 2D hand scans. And we had needed for that 75 student assistants and 12,000 research hours. And 1,500 children reached out to our outreach workshop because they liked our workshops to design some small things. And there are two, as already Sandra said, the two technical reports, and they are already published. I did not know yet, but and herefore comes also my plea. I would recommend, if the CEN people are listening, I would recommend and wish that the CEN staff would use DINET platform in their business model somehow to present the KIT scan data and other data to designers and researchers, because it's much more richer than seeing a table like we saw that in my first, when I was a student at mechanical engineering in 1975. And now you can play with the data, and you can. I think it's better for the designing and give better results, and also it will give less accidents if you can use the data in a proper way. And one last slide. One application, a mask fit project, and 50 years of lessons. This is my last one. I learned that to ask people where are we designing for, and you measure diversity, and don't use the average person. And DINET is open, free, and is an effective way to spread a good practice. And then this slide is not, oh, it should be, I would like to thank my co-authors, but this doesn't come through. My co-authors is Renate de Bruin and Professor Ignacio Castellucci, Toon Huismans, and Marijke Dekker. And they are all in the papers. If you Google my name, you will find them, and all in ResearchGate and in Scholar Google. So thank you for listening. And if you have questions, please let me hear them.
Okay, thank you very much, Johan, for sharing with us all the experience in anthropometry, in applied anthropometry in product design, your experience in 50 years. So it's time for questions. We have several minutes for the questions. So the first question that we have in the Q&A, it's related to the way of measuring the height with the shoes in, and then subtracting the heel height.
Yeah.
The question is that seems like there could be a lot of variation between different shoe styles and brands.
Yeah.
And how you deal with this kind of
because
variation?
We thought about that because you measure individually. So if a person is 160 and the heel height is 4 centimeters, then you subtract 4 centimeters from the 160, and you have the height is then 156. So it's very individual. There's not much a mistake in there, and we always learned also with the elderly that it depends on the instruction. The posture is very important in measuring anthropometry. So you have to ask them to stand upright in the field. That's the German school. In the English school, it is different. They measure children on the wall, and then sometimes even they stretch the children a little bit. So they could be 1/2 centimeter taller to the English school. But I follow mostly the German school, that you measure in the field and ask the people to stand upright and the head in the Frankfurter plane. So that's is according to the standard. And subtraction of the heel was very effective for us. And besides, it has also a result that we could see the variation of the heel heights in those days, and that was also extra data.
Okay, thank you. So the second question is, thank you for the interesting overview. It all started with the 1D table, which are still used a lot. Do we also need an update of this 1D data to be easily used by non-experts?
Do we need an update of that 1D? Yeah, we would need them, and that's a good question, because always I get a lot of questions. Why did you not measure let's say the Dutch adults every year? It's just a matter of money. In the 80s and the 90s, always say the measurement is about 10 euro per measurement per person. So it's a lot of money to measure people. So if we don't have the data, we have to estimate it, and that's also a role of an anthropometric experts. We can, based on our knowledge, we can really estimate measurements which are not measured.
Thank you. So next question, it's about digital human modeling, and what's your favorite digital human modeling tool and why?
Yeah, we used them in the 80s and 90s very much, but recently I did not use them. I think when we got 3D models, 3D scanned bodies, we used them. I don't use computer models so much. We made one in the 80s ourselves. We called ADAPS, Anthropometric Design Assessment System Program System. And then it was a very simple model. It was used widely by our students, but currently it looks very old-fashioned. I know there are much more computer models, but yeah, we have even tried to develop our own by a student, but that should work with a design program, and that is not so easy. So no, I have no recent experience with working with surface computer models. We use 3D scans.
Okay, thank you. Next question, it's about the 5D model. Will there
Yeah.
be applications of 5D within the novel technologies, such as those in wearables?
Yeah, the example where I used the definition from 5D is more or less related to children with breathing problems. So they have a ventilation mask that doesn't fit well if they put their head on a pillow, because some parts of their body will shrink and some part, the bony part, will fit. And so then you get leakage between the mask and the body. And to estimate that well, I think people like Toon, computer scientists, would be able to cope with that. But yeah, that still has to be developed further. So it's just the start of a new part of the anthropometry.
Okay, and another question, it's thank you for your interesting presentation. What challenge did you experience when measuring children? What is a challenge to get parent consent?
Yeah, that's not an easy one. You have to find the trust for the elderly. We first try to do it via schools and teachers. And we also experience that if you ask it on high schools, we get mostly no, because they have a lack of teachers and don't have time for other scientific stuff. So, but on ground schools, basic schools, then we were able to, it cost a lot of effort to get the schools to the faculty. First, we tried to get the 3D scanner to a school, but in fact, it cost a lot of time to get the right way. And then we paid the bus from the school to the university. And in fact, it was a marketing trick, you could say. We said to the school, we teach them through a workshop in designing a certain thing. So they came for the workshop and were allowing that we measured them for one morning or one afternoon. So you must be aware that measuring is our goal, not their goal. Their goal is to learn something new and funny.
Okay, thank you, Johan. This is the last question.
Okay.
So it's almost 6 o'clock, so we are on time perfectly. Thank you very much for the collaboration and for participating in this webinar series. And I can say that stay tuned because we are going to continue with most presentations in maybe September.
Okay, I liked it very much. Thank you for the invitation, and I hope people can use the story I told them.
Okay, thank you. Thank you very
Okay.
much. Bye.
Bye-bye.
Thank you.